here's going to be our last video of the week related to applications using systems of three linear equations. So you can read the context here. Okay, there's a little bit of background at the beginning, but the important part of the prompt kind of starts here. So suppose that a fertilizer has twice as much potassium as weight as phosphorus. So potassium, they're saying is K, so whatever K is, it is twice as much as phosphorus. Okay, and then in the percentage of nitrogen, okay, is equal to the sum of the percentage of phosphorus and potassium. So phosphorus plus potassium. And then if nitrogen, potassium, and phosphorus make up 42%, okay, so all together, if we add phosphorus, potassium, and nitrogen, that should be 42%. We want to determine the proper NPK label on the fertilizer. Okay, so just rearranging this is our system of equations. We can write this now instead. Well, actually, it's all set up to do, I mean, we can rewrite it, but it's actually all set up to do substitution. So if we substitute this into, if we substitute the first equation into the second equation, then we can say that N is equal to P plus 2P, or rather 3P. Okay, and then substituting all that back in here, we get 42 is equal to P plus K is the same as 2P, and then N is the same as 3P. So then altogether we have 42 is equal to 6P, or P is equal to 7, and then consequently that means that K is 14, and then N is 21. Okay, so the label should be, let's see, N is first, so 21, P is next, 7, and then 14. All right, so that should be our solution for this one. Next, another example. This is a modeling example. So we want to find this position function where s of t is position relative to the origin, and then we want to find values of a, b naught, and s naught using this information. So I'm just going to take this information, substitute it into the given equation, and each substitution I make should give me an equation. So for example, s of 1 is 30, I'll have s of t is, that would become 30, and then plus 1/2 a t squared, so t is 1, I'll just write this in 1/2 a, and then t squared is 1, so just 1, and then plus v naught plus s naught. Next, when I go ahead and substitute that in, that's 54 is equal to 1/2 a, and then 2 squared is 4, so that's there, plus 2v naught plus s naught. And then lastly, 82 is equal to 1/2 a times 9 plus 3v naught plus s naught. Okay, so plugging in t and the corresponding value respectively, we get to this system of equations. All right, so kind of going through and solving this then is our next task. I'm going to encourage you to pause the video, try that out, and resume the video when you're ready to see the solution. And here's my answer using that system of three equations. So in the first equation, I just solved for s naught. I don't know why I picked that one, I just did. If you happen to choose something else, that is fine. And then I went ahead and substituted that finding of s naught into equation 2. That led me to say that b naught is 24 minus 3/2 of a, and then I went ahead and substituted that in for v naught, and actually I substituted that into v naught into s naught. So just rewriting that equation, and so I have s naught as 6 plus a. I took both of those findings and then used that third equation, which I haven't used yet, substituting each of those in, cranked it down, and I got 4 was the value of a, b naught was the value of 18, and S naught, actually, I'm sorry, S naught should be 10. And that was the original problem. If you're interested, I went ahead and wrote the equation out. You don't have to, but know that you certainly can for just a little extra practice.